Welcome everyone. I'm Dinesh Dutt. I'm the chief scientist here. I will be talking about data center network architectures today, specifically not about the details of the data center network architectures because many of you are, or if not all of you, are pretty comfortable with all of this, so I don't want to waste your time explaining what's pretty obvious to you, but to talk to you about how, from an architecture perspective, JR talked about the philosophy. I want to talk about the architecture. Matt will talk about how it's actually seen by the customer, and David will talk about the real world examples of how people have actually talked about it and seen it. The point is that this is not something that we are doing as a one-off thing. We are looking to build this from ground up to be something that others can build off of. So when we say we are enablers, not gatekeepers, we are trying our best to do things so that network becomes more accessible and more open so everybody can participate. That's what got us into the world that we are in today, and that's what we would like to accelerate. So with that said, thank you for taking the time again. So what we notice is that there are three prevalent architectures in the data centers that we encounter. There's a classical layer 2 fabric which runs with MLAG, and essentially it's a drop-in for existing architectures. For various reasons, whether it be because people have the existing infrastructure and their knowledge base built around L2, or because they have applications which they have no control over, which are structured around L2 requirements, whatever it be, there are people who still do L2. They just have a small scale, they just want it. Then there is the classical, this is the fabric that made the data center that we know of today. Today, if you see all the revolution, 2008, I was vesting in peace in Cisco. I had nothing really going on. Everything was fun. And, but, this changed. Networking was boring. Nobody was talking about networking, but today everybody is talking about networking. And if you want to look at a few things that made that happen, this fabric, which is actually, there are many ideas that are floating around in the world today, which are actually kind of a throwback to the 50s and the 60s about centralized ways of doing things. But this is a throwback too. This is a fabric that was built by a guy who in his time was running into the limitations of technology, just as the people today are running into the limitations of the technology. And that technology limitation was around voice. He was having difficulty, Charles Class was having difficulty building equipment that could deal with the call volumes and the sizes that telephony was expanding. So his basic idea was, how do I build a large network out of small blocks? And that is this fabric. It's funny, if any of you can find a picture of Charles Class, it'll be great. In this world of YouTube, I can't find a picture of him. Because to me, he did something that was really clever. But anyway, this is the modern data center fabric, and what enables this is several characteristics. First of all, it is scalable, it's extremely flexible, it is dealing with the characteristics of modern data centers, which is fine-grained failure domain. The cleverness of the network or the durability of the network is not in any one individual piece, but it's in how they work together. It's an emergent property rather than something that's fundamental to just a block. And typically people deploy it with IP. We sometimes see MPLS, but that's typically deployed with IP fabrics. And then coming after that is the layer 2, is the network virtualization over the IP fabric, where people say, I have a fundamental fabric that works well, and if I have characteristics of applications that work better, then I want to move that out of the network and into the application itself. Martin Casado and I wrote a white paper, or rather an article on his blog, Network Heresy, where we say, if you look at the internet today, the fundamental reason why the internet has succeeded so much, you watch Netflix. I worked on ASICs that did microflow policing and QoS of all kinds. You bet those are not enabled on any of the boxes that are in the traffic pattern from Netflix to your screen, because they're too complex to manage. And the network bandwidth that was good enough as it kept increasing and became simple enough that they moved the complexity into the application. And that is what made the internet succeed the way it is. And the fact that you have a fabric that provides that same basis for being able to build scalable, flexible, generic architectures is allowing you to be able to say, move things off and have the network virtualization become an application. It is not something that's part of the network, it's part of the application. No one talks about trying to say, how do I hardware accelerate Hadoop network, right? No one's trying to put Hadoop protocol into the hardware, into the ASIC. The moment we say network virtualization, everybody thinks it's part of the network and it has to be tied in and somehow completely enmeshed, which means what? You're back with a 24-bit VLAN mess. And that's what we don't want. And so a lot of people are saying, if I want really large, scalable, flexible, generic architectures, I will have a fabric that's rock solid and I'll do everything inside the application. Those are the three prevalent data center architectures that I notice in my time in my previous life and over here. Do you guys tend to see the similar things? Do you see different things?
That's it. Now, the real question is with layer 2 fabric. Today you have 2 spines. Are you going beyond that, or is that it?
That's it. To us,
cool.
Yeah. So the basic idea is don't attempt to kind of,
It's got to pass. Just
yes.
There'll be something worse down the line.
So moving on. So to bring the networking for the modern data center, if you want to make networking a first-class citizen, our basic idea is to make network accessible and to make it a first-class citizen. When James Hamilton said network is in the way, that's a thing that I felt like I, as a network engineer, had failed somehow, even though he was not talking to me personally. But how do we make networking accessible? I mean, if you look at the internet today, the reason why TCP/IP won over at the end of the day is because unlike IPX and everybody else, it was open. People could go sit down and innovate. Today, people don't innovate with the network, they innovate around it. The network is a black box and you move everything out of it. If Ivan, for example, wanted to make an enhancement to BGP protocol, he has no choice. He either is in collusion with the vendor itself to get that done, or he tries it on some x86 and says, hey, here is a demo, somebody's interested, if you want, please. Here, you just go on and
or
do
use
it.
OpenFlow.
Yes, or you can use OpenFlow. And coming back to that, our idea is to keep networking open so people can actually play with it and not have to reinvent the ocean. So with that said, how do we go about simplifying the networking, and how do we allow innovation with the network rather than around it? So simplifying networking, what does it mean? Simple fact of life is you need simple building blocks. It's not the most complex building blocks that are interesting, it's the simple building blocks that are the ones that lead to the most flexibility. Someone said, simplicity leads to flexibility. If you have less, you just become more flexible. If you have more, you just are hemmed in by all the choices you have, and you run into analysis paralysis sometimes. I mean, you give a little block to a kid, they find 60 million ways to play with it. You give them a robot, it says a particular thing, it does a particular thing, 10 days later they are not excited with it anymore because it does the same repetitive thing. So simple building blocks have several interesting emergent properties. First of all, network operations become simpler because you know what each block does. It does that one thing and it does it well. Failures become simpler. Today, when you look at large chassis, when they fail in complex ways. This was something that a real customer came to me in my past life and said, Dinesh, when things fail in your box, it's very hard for me to know what's going on. And I sold my firstborn to slavery just so I could buy that box. And now if it fails, is it that the line card didn't sit properly? Is it that the black plane is messed up? Is the CPU on the line card busted up? Is it the CPU talking to the line card CPU that's busted up? I mean, where do I debug it? And I can't just go keep running because don't have many of those lying around. So when failures happen with simple building blocks, they happen in simple ways, and it's very easy for you to just throw one, keep it going. Because again, the strength of the whole unit comes together, not in any one individual block. And then, of course, networks, because of the fact that they are simple building blocks, they become more flexible, scalable, and agile. And we'll talk about each of these as we move forward.
Can I just make a comment?
Absolutely.
Totally agree with all that. And we had that 30 years ago. And then the customers forced us to go into bigger boxes. The carriers wanted CRS-1 and the enterprise customers wanted the big 6500s. So how are you going to cope with that?
So I think multiple ways we all learn over time. We had that initially, and people thought that building larger boxes is really the answer to many things. And the primary reason why people felt larger boxes are actually the answer to things is because many of them had command line interface to do with. If I have to log into 15 boxes to figure out what the heck is going on, it's phenomenally hard. Whereas if I just log into one box and do it, it's simple. What people have learned from then is that you don't log into 15 boxes, you have a script do it. That's not the job of a network admin to sit down and log into each box. If I want to reboot 1,000 boxes, it's easy. I mean, when one of the technologies that underpins the so-called SDN revolution today came about, I was in my past life, and a large customer said, we want to hear what is your answer. So we went up to them and we said, oh, this is complete garbage, doesn't do anything. Who the heck cares about any of this? We'll come up with a far better answer and it'll be really cool and you guys will love it. They said, cool, when you have it, come on over and we'll test it out for you. So I said, I'm happy to do all that, but just tell me one thing. You have that. Imagine you have that today in your labs. What will you do with it? And the guy said, oh, it's very simple, Dinesh. VLANs. I'll configure VLANs. So, sorry, I'm giving you a flexible 488-bit key to configure VLANs. I mean, what are you doing? And he said, Dinesh, you don't understand something very simple. I have 100,000 servers. I know how to control it. I have 100 of your boxes. I don't know how to manage it. The problem with networking isn't networking, it's the managing of it. So all these people who wanted these larger and larger and larger boxes wanted to jump in and wanted to type it. If I have to go to 15 boxes to type it, it's very hard. JR,
Yeah, so
I think
I was going to kind of jump in a little bit. One of the things that we've noticed, we have some customers that have extremely large networks, and they're using the principles that Dinesh talked about and using small building blocks in class topologies to build massive scale. So they have, we'll call it a virtual chassis that's way larger than anything you can build with a CRS-1 or a Catalyst 6500 or anything else like that. And what they've recognized, as Dinesh is kind of pointing out, is the interactions between those building blocks are simple and straightforward. The protocol interactions are well understood. They're not proprietary. The underlying hardware is grossly understood. You know, let's say, for example, a Broadcom chip. Sure. All the Broadcom chips work the same way. They grossly understand how they work. It's not like I have a line card chip and a fabric chip and a fabric scheduler and a backplane chip and some SERDES and some, you know what I'm saying? Yeah. So the complexity of the chassis systems kind of built itself up mainly in that world when the networking space was dominated by hardware. What can I really pull off in hardware? At the time when something like the Catalyst 6500 started adding SUP 720s and these crossbars and all that, we didn't have a single chip, solution that could move, 3.2 terabits or 6.4 terabits. We have that today. So the question is, what do you do with it? I think you're going to find sometime, either if you went online today or you go online later on today, you're going to see an interesting announcement in the industry. It's somebody's put up a modular platform based on what we would call a class-in-the-box architecture, and it's basically all the line cards and fabric cards are independent. They all run their own separate CPUs. They all interact. And from a software perspective, if we were to work on that platform, we would have every one of those components interact through a standard protocol set. Really straightforward to understand and diagnose. And so that's what we're seeing happen.
And like I said, Jared pointed out again, the technology is evolved.
I like this approach.
The technology is evolved and people know how to do these things better now. So how do we do that? How do we simplify that? So for each one of the three architectures, rather than beat up and say, that's the reality we live with. So rather than change people's minds, we can say, let's see what we can do to make your networks more accessible. If you look at layer 2 networking, the primary problem that I run into all the time is the clutter. You have UDLD, you have VTP, you have GMRP, you have this, you have that, and every version of every protocol is different with every vendor. That's a pain. Even spanning tree, how simple can a protocol be? Spanning tree, how many variations of that exist out there? And I was responsible for making some of them fast, but the point is that there are just too many of them. If we all agree that MLAG is the base technology, and that's pretty much the base technology, just simplify STP to be the fail-stop mechanism, meaning simplify your configuration so that it's just a single instance. All it is a fail-stop. It's not doing anything else. Why do you need to try and complicate it by adding more layers of, do I have a common instance spanning tree? What VLANs go left? What VLANs go right? Don't have to worry about all of those things.
Can I ask a clarification question? So when you say MLAG is the base technology, you're talking about host attachment, I assume, correct? Or are you talking about the entire fabric?
So when there are two pieces. Thank you for pointing that out. There are two separate pieces. One is host connected up. Those who connect up hosts and want to do from there layer 3 up, that's MLAG only to the host, and that's trivial. There's nothing to be done there. But the people, when I say layer 2 architectures, they are people who actually go all the way up and they have MLAG. Yes, I have tried that, and I was the one who had to do that. So I said, okay, got to support that. That's just the way things are. And rather than fight around it, let's talk about making that actually become something that people can work with, rather than say, L2 is easy. Really? Have you sat down and looked at the last L2 config and configured it? Compared to L3, that's actually much harder. But people don't have that. There are lots of, history is funny. As someone says, history doesn't repeat, it rhymes. But sometimes it doesn't even repeat itself. It doesn't even rhyme. It just stays there and people keep repeating the same thing over and over again. Oh, the other day I was sitting with this customer and he was seasoned. So I presume that's part of the reason why he said, Dinesh, I like your idea, but L2 is actually slower compared to L3. What? In what age were you living in? I mean, that is no longer true. And yesterday, Davidson was pointing out, he read a blog where someone recently said L2 is faster than L3.
Sure.
Question about the MLAG.
Yes.
I've run into cases recently where variants of MLAG from whatever vendor aren't aware of link degradation or link failure. And I see degraded links as a growing problem where you're losing a small percentage, but it stays in there and your port channel, your MLAG, is getting clobbered.
Yep. Absolutely. And that's not the only one, right? Again, over there we can do things like, for in Linux, you've got things like min links where you can say, if I have fewer than these many links, shut the channel down. And again, this is an example to me of what JR was pointing out. If you have the base technology, there is so much you can build off of, right? I mean, you don't have to reinvent the wheel for everything. And
Peter, in this case, what you do is you write a Python script that monitors the counters on the interface. Errors go up. You shut down that part of the link.
Or EM, but I'd like the vendors to do sort of OAM, basically, is kind of where I'm coming from.
That's a fair way of looking at it. And I think Yvonne just pointed it out. From our perspective, that's exactly what we would do. We have some customers that do exactly what he said, which is to write a Python script or a Bash script or something like that, kind of do the gross level monitoring. A customer doesn't, the broad base of customers doesn't want to maintain that. So we'll do it, and we'll monitor it in QA, and that'll be one of the things that gets added to Cumulus Linux over time, or maybe somebody else will do it, and it'll get added to Cumulus Linux. The interesting point is that you could do it today, and what you did could be the solution that gets maintained over time, whereas if you were living on some other platform, it's not open. The platform is an enabler. It's closed. The vendor's supposed to write it and do it for everybody, and nobody has visibility to how it works.
I like hearing QA because without naming the platform, I've seen another platform with a large number of scripts, 90% of which were crap.
Yeah, well, I mean, that's what we do, is a ton of QA.
I mean, that's part of the point, again, earlier that JR made is two things. One is just throwing it over the wall and saying, hey, I got a GitHub repo, it's done, is not done. I mean, that's why we take the time to push these things up, reorder it in a way that is actually mergeable upstream. Think about what it means to be upstream. We want to go back to rough consensus working code. But again, to move on to this, we want to use standard defensive techniques. Today you have UDLD, you have 10 gig has its own way of detecting unidirectional links. Just use bridge assurance, it's a standard. If your vendor doesn't support it, ask why not. Because that's a standard IEEE way of doing it. Just do bridge assurance. It prevents, because the way it does spanning tree, a fundamental difference between layer 3 and layer 2 is layer 2 fails open, layer 3 fails closed. Meaning, if I can't hear from you, you must be dying to hear from me, so let me tell you everything I know, versus if you don't want to say hello to me, I shall go my own merry way. So enable bridge assurance and you get fail closed behavior. So do simple things like that. FHRP becomes trivial. Don't sit down and spend time trying to configure active HSRP, active VRRP, GLBP, all of those things. Just use virtual IP MAC. The ARP will keep the MAC table hot and eliminate complex protocols. What is the theme about layer 2 networking that we want to point out here is you can make the networking copy simple enough that you can manage it, automate it, and troubleshoot it. That's the point that we want to keep repeating.
Yeah, but you are lucky enough that you are a startup. So you don't have 20 years of history of failed attempts that you have to support forever.
You're right, and that's actually kind of fundamental in that by being a startup and being able to start from scratch in what we believe is kind of modern era networking, we're able to learn from others' mistakes and discard technologies that we believe are not going to be relevant looking forward.
Yeah, just do things one way.
Right.
You don't have to do them 5 ways.
And so, as an example, our first product set that came out was very IP routing focused. We didn't have, it supported bridging and that sort of thing, but we didn't have MLAG. We added MLAG, which we generally think of as a step backwards, but we did that because there's a large set of customers that need that transitional step. Some of the ones that want to build a very cloud-centric data center, which Dinesh will get to in this last part around network virtualization, They needed MLAG as a transitory technology. How do I deploy this stuff, get it standing up with MLAG, and then re-architect my software components or my configuration to take that whole pod and turn it into a network virtualization overlay IP fabric?
And to the point that you make, you're absolutely right. They have a lot of, and that's a weapon as well as today when we get into some accounts, what we are asked is, why don't you support UDLD? Because UDLD is what I know. Bridge assurance, what is bridge assurance? Does a vendor even support it? I mean, is it something that you guys are doing? Is it a Linux thing? People are not even aware, right? There is one part is awareness, one part is, any company that starts and wants to be a forerunner will do things that are ahead of its time. The question is not whether you are ahead of your time. The question is also how much you follow through with the education. It's like the same thing. Yes, you take the first patch, kernel patch, and you put it out, and after that it becomes a by the way, and you never bother with it, right? You got to keep the integrity up of trying to keep things simple, because if the focus is to keep networking simple, it's to try and make sure that the clutter is less. So layer 3 networking, IP is the base technology, sometimes MPLS, but people know this very well. This is what runs the internet. It's mature, it's sophisticated, it's scalable. All of these are proven ideas that run on it. It's the basis for all the large-scale data centers that I know of. And it's based on standard technologies. You're not sitting and worrying about proprietary ways of doing the same ECMP or proprietary ways of doing the same thing. Today, if I have 3 different MLAG protocols, I don't even know what they talk to each other because that's a proprietary protocol. We hope to fix that, but that's what it is. The primary challenge is that it's considered hard to configure. It's back to the question, oh, but you know what? To put a very poor joke that I heard, but it's still funny is, Mama, is it going to hurt me when I pee? It's really poor, and everybody I run into says, IP is so hard to configure. I have to configure IP addresses. I have to do this. I have to do that. Why? It's not really that hard, and we'll talk about how we look at that. But the primary challenge is that it is considered hard to configure, whereas L2 is considered easy to configure. But the important point is easy to configure does not mean a single point of management. Easy to configure means that it is really easy to configure. Just because I have 10,000 nodes to configure and I have to configure it from one single point that I have to type a command 10,000 times doesn't make it any more easier than if I had to go to 10,000 boxes. Yeah, slightly, but not too much.
By the way, now that you mentioned MPLS,
Yes.
you plan any MPLS support?
Yes. I think MPLS is one of those things that has certain interesting properties, and we see value in it.
So just to make sure we shape that correctly, we have one customer that's in trials around MPLS right now. One of the things we're deathly afraid of is recreating the protocol alphabet soup that exists around MPLS.
Yes.
So we're dipping our toes extremely slowly into the space to make sure that the answer that comes out is something that's sane and tractable. So we can't tell you what the answer is going to be because we don't know yet. We assume that sometime before the end of the year, it'll actually become much more clear and available to the whole set of customers.
Let me guess, that customer wants static labels, right?
Yeah, effectively, they want labels that label paths that are pre-calculated and distributed.
Yeah.
Right.
Put it another way.
We actually think it's somewhat sane and tractable. LDP and RSVP TE is kind of
And MPLS down to the servers, right?
yeah.
Okay.
So,
Almost sounded like
Enough
you know
said.
something about MPLS.
but the point again is when I was approached and asked to look at that problem, and I suggested static label. The basic idea is if you want to use VX, instead of a VXLAN, you want to use MPLS as an overlay. It's an encapsulation and it provides you, and you've got the tools and the skill set for it. Why do you want this thing that changes debugging, makes a debugging mess by changing the label value every hop, right? Why don't we start with something simple and static that you can actually understand and you can trace the packet through? And it was a well accepted idea at that time by the customer or potential customer. So anyway, what are the principles?
I thought we were referring to why doesn't OpenStack use labels on the inside the edge?
Well, OpenStack is a whole different beast that Matt,
I'm sorry, I said OpenStack, OpenFlow. Brain not working correctly.
Okay.
In other words, why do we want to match on a 12 tuple when we could match? But maybe that's a side conversation.
That's SDM version 2.
So, but a lot of people
It's
have come to
already
similar.
being written in papers.
Yes.
Don't worry.
Exactly, and that's essentially the point, right? A lot of times you will find at Cumulus, There isn't aha technology. It isn't that we believe in aha technology. If anything, we take our time to not come up with new things because there's a lot of stuff that works very well. Let's not throw the baby out with the bathwater. So why invent a 488-bit key when I can get away with a 24-bit key, or a 20-bit key? So there are various reasons why we don't. But anyway, without getting there, so if you want to simplify configuration, if I want to configure 1,000 boxes, so Dinesh, I'm sold. I like these little boxes. I like the simple building blocks, but I still have 1,000 of them. How do I go about configuring? You haven't answered that. Well, one is automate it. So how do you automate it? First of all, you try running with a cookie cutter configuration, also known as substitutability, meaning one box looks very much like the other. And therefore, how you configure it looks very much like any other box, which means you have as little node-specific variation as possible. If I have to put in a lot of IP addresses in every configuration file, that's not node-specific. That is a lot of node-specific variation in my mind. It's not something that you can take from one box and slam it down on the other. The other is you want as little duplication of information as possible, because when you're configuring all these boxes, you make silly mistakes in your code or in whatever you generate. It is easy, right? To err is human. To err a million times is automation. So you don't want to make it go there, right? So you want to make sure that duplication of information is kept as small as possible.
Who's putting on Twitter, so I'm not even going to type this time.
So the other thing is that you want to do as much configuration but not more. And we want to make sure that there is good enough networking. There will be people who will want to twiddle every single knob that exists in BGP, that Ivan may have to actually look up the book to figure out what it did and which version of a particular software. But the point remains that that's not necessarily what we are trying to achieve. We are not trying to give everybody every single knob to twiddle to make it easy for the large consumer market. I mean, take a look at the boxes. 10 years ago, everyone here would have had a Windows laptop. Everybody I now see is running a Mac. Linux has been trying that for a long time.
I'm the one Windows.
Hi, everybody.
Linux too. Do you run Linux?
PC. Hi, I'm a PC.
Do you run Linux?
No.
So, but one of the things that Mac did,
Had an opportunity to say.
one of the things that Mac did very well is that it said, it's Unix underneath, and I will make the problem simple enough that I will run with it, so that for the mass customer, it actually does what you want it to do. You don't need to know the 16 different options to encode FFmpeg from an MP3 into an AAC. But anyway, what we want to do is make sure that you can do it if you want it, but it's not necessarily something that we want to shoot for. And if it's simple, it's automatable. So why don't you just do something that's very simple? So the first thing is separate the problem from the solution. Use something like Prescriptive Topology Manager, PTM, to verify connectivity, right? Anybody looks at this class, the first thing they do is run into lots of cables. We have a customer who's got about 200 plus racks. They said they had a 20% error rate in their cabling, and PTM saved the day for them. And so you verify connectivity per topology using LLDP. It's a very easy to write script. I mean, this is very simple. S1, P1 port, switch 1, port 1 is connected to middle tier switch 1, port 3. So it's very trivial to configure that, look at that, you get it verified every time a link goes up and comes down. Every time LLDP changes information, you know about it. And you can act on that information, and we'll talk about that. You can take dynamically defined actions, or you can run with predefined hooks. We come with a predefined hook into the routing suite, but if you want to do your own predefined actions, that's possible. For example, if the hardware supports blinking the bad LED, cabled LED, you can go ahead and write a script to do that.
That's pretty cool. So you have it set up so yeah, check them all out.
Yep.
And then go and blink that one, so I can say, hey, you go down there, check that out.
Yep.
You'll see which one's the wrong one because the light's flashing.
Yep. We don't have that. Not every hardware supports changing the color or blinking it, but if they do it, then that's great.
That's pretty cool.
So the next thing you have to do is when you pull out the cable, the right port starts blinking.
Yes, we'll get to that. So the next thing is you simplify the routing configuration. Take OSPF. A lot of small customers, the other thing a lot of times we encounter is, oh, you guys are for the big guys. You are not for the small guys who actually understand. So this is just OSPF is very commonly used for small guys. A lot of small people use it. If you look at the OSPF configuration, looks like cookie cutter, right? There's nothing here. Every line is repeated. It's IP OSPF 000, IP OSPF network point to point. It's pretty much the same. The only difference is one, which is the router ID. And there's a way to fix that too, and we'll talk about that in a second. But OSPF is simple, but a lot of people want to go to BGP. So,
but by the way, in the previous slide, you're using unnumbered interfaces, right?
yes.
So you don't have to configure IP addresses on the uplinks.
So let's walk that through for 1 second, since you're asking me a very detailed question. First, this configuration works independent of IP unnumbered or numbered. It's exactly the same. But if you want to reduce your configuration, then have as little links as possible, right? Today, everybody is understanding 2 or 3 important things. First is that those link IP addresses are not that interesting. Second, they actually take up valuable fib space because you don't want to run into millions of fib spaces when they are really large networks. Third, each one of those addresses is an attack vector. That is why with V6, if you run everything with link local, it's much nicer. And we'll get to that step by step. But yes, in this particular topology, actually, I kept it completely agnostic, whether it's unnumbered or numbered. It's the same topology. But it simplifies your networking interfaces configuration.
Just on that, just got a question about using PTM, whether it can impact the routing adjacencies, if you can do any integrations around that.
I'll show you that in a second.
Yeah, perfect. You make Matt Oswald happy.
So the other thing is BGP configuration, right? Everybody understands BGP configuration is nice. A lot of people in the data center understand BGP is really a powerful protocol compared to even OSPF, for example. But the trouble with BGP is that it uses IP addresses to talk to neighbors, to set up neighbors. Wouldn't it be nice if I could actually use interface names rather than then that becomes cookie cutter again? And one of the innovations we have done is to make it work so that you can do BGP interface-based configuration. And we can get into how, and I'll show you a quick demo. There are 5 ways to go about doing it, but essentially you can reduce it. So you say neighbor SWP1, remote AS 64500, and you essentially repeat this configuration. Those are your spine, those are your TOR, and it just works. This is an eBGP configuration.
One additional idea.
Yes.
Why don't you just negotiate dynamically the AS numbers?
Yes, we'll get to that in 1 second. So this is a way whereby we simplify the configuration completely. The next thing is, what if you change it like this? You don't even have to type in the AS number. You simply say, are you setting up an external BGP connection or an internally IBGP connection? I can show you that. We have a demo. So essentially this, and now you convert the router ID. Instead of it being a string, you simply say LO, which means take the loopback IP address and use that as your router ID. Now this means this configuration is cookie cutter. I mean, look at all the different boxes. It looks the same.
Now, where are those people that claim that BGP is complex?
All those blog posts you had, Ivan, with all those questions that were after your simple explanation of it. So in any case, but anyway, thanks for that blog post. It helps a lot in many of the, again, to me, just because you can, don't do it, right? I mean, this is one of the things. BGP is a very sophisticated, mature, and complex protocol, but in its heart, it's actually very simple. It's very, very simple to understand. And JR and I had many debates when I first came to this company. He was very much an OSPF man. I don't know if his heart is still in OSPF, but he's now a BGP man to some extent, I would say. And I think BGP, one of the beauties of it is it's simple enough in its heart. Yes, it gives you all those other things that you want to play with, go ahead, but you don't have to, right? You can keep it simple. Again, just because you can, don't do it.
Now, are these configlets here, is this kind of pseudocode, or is this actually a Quagga configuration that...
It's a demo. It's actual Quagga configuration. This is not pseudocode. I mean, to be fair, let me be very precise. The remote AS external is something I coded up the last 3 days ago because I had the idea. But I knew Ivan was coming. I had to have something for him. And he sent me telepathically this thing which said, like, Dinesh, do something about it. So in any case, have this. It's working. This is standard Quagga config. This is not stuff that is, how shall I say, that is there. It's a nice idea. One of the things again at Cumulus is there are many of these ideas that just last week I was talking to a customer and he smiled and said, Dinesh, this is some of the stuff you were talking about when you were in the previous company too. I said, yes, but there I just talked. Here I actually do. So here you can do. The power again of a simple system is that you can build and everybody can add to it. Right? I mean, that is again to me the openness and the simplicity of a simple platform is the people who can contribute and configure to it, as opposed to saying it's only those guys who have got really dark rings under their eyes who know how to configure these things. I'm being told I have not much time. So once you have been able to configure all of this, you can essentially reuse the server management toolkit, right? I mean, one of the things people ask us is, why are you running with Linux? Why do you do Linux? Why couldn't you have put everything in some blob just like everybody else? Well, one big advantage for us is that now we just look like a server with all these NICs, which means we don't have to reinvent the network admin toolchain. It becomes a server admin toolchain. They are identical. So just the way we unified voice and data networks, why don't we unify the server and the admin toolkit? Because that is much more sophisticated today because it's open. It's been having a lot of maturity. It's got a lot of vibrant communities. Why reinvent the wheel? Another joke someone told me was, Dinesh, the trouble with networking people is they think every solution ends with a protocol. Configuring, booting a box with a new image is not a protocol problem. Package management is not a protocol problem. We don't have to reduce everything into protocol problems. There are other ways to solve it. Let's just take an operating system that does that, just go with it. Why do I have to reinvent package management? Is that what my skill is about? So once we do that, the other thing we have done is, okay, I can do all of this stuff, but you know what? Unlike other servers, other services that run on a server, I can just modify the config file, say reconfig, and the box will just run. Whereas routing, how do you do that? How do I just make it take a difference and run with it? So we use if reload for layer 2 and network configuration, which is just essentially HC network interfaces, and we use Quagga for routing constructs. And there are also CLAG and switched, but they were already that way. But essentially, if reload and Quagga, today you can just give it a diff and say reconfig. Put a new config file and say reconfig, and it will just do the diffs. So BGP sessions, for example, if I have a session with Ivan and I have a session with JR, and Ivan does not want to talk to me anymore, and you want to say no neighbor BGP, and you just give it the configuration without neighbors, without Ivan's config in it, we will automatically remove Ivan as the neighbor. This is there.
So you implemented SIG hop in Quagga?
Roughly, yes.
Finally, someone.
So this is available for Quagga now.
2.5.
Yeah. Yeah,
Cumulus Linux 2.5, yes. This is in Cumulus Linux 2.5. It's an experimental feature, meaning you got to go and actually say, yes, I don't want to do this.
Experimental meaning...
Don't call us.
You did it a couple of weeks ago in the middle of the night, and it may blow up, or experimental
No.
as in, yeah, it's pretty close, we're just not...
No,
quite
so
fine.
there are various ways to look at it, and some of them, yes, I coded it last night, but in this particular case, that is not the situation. But you know, let's be very clear, we don't put out code that has not been somewhat QA'd. QA is fundamental to us, right? I mean, otherwise, what are we but just throwing together packages and putting it out? We have a QA that validates every one of them. They throw their works at it to make sure that routing works, right? I mean, for us to be able to run in one of the largest data centers in the world and have very little downtime means that we spent a lot of QA effort trying to make sure that the software was rock solid. So we put in a lot of effort. So in this particular case, we have done a fair bit of QA, but if you look at what it does, it's something very fundamental, right? I mean, you are essentially saying, I have taken Quagga, which does not have a diff engine, and I've added a diff engine to it. Do we understand every single customer's configuration out there? Not yet. We have not had that experience, but we have had a fair bit of experience with a lot of large customer configurations that we have tested and verified works. So we say it's experimental because we may not know what your specific configuration does, because if you do something that's a little off, maybe we didn't catch it, we will catch it as a bug, but it's been tested, it's been verified.
So for some unspecified subset of features, you actually tested it, but you didn't test every possible combination.
We tested it for a whole bunch of configurations, but every possible combination, no.
Yeah.
So Dinesh has to get ready to stop because he ran out of his turn. But specifically around this experimental question that you're asking, pretty simple construct, right? When you have something that we've worked with, we believe works reasonably well, we like to make sure that customers can highlight it and understand what they're walking themselves into. They can choose to use it, they can choose not to use it. More often than not, the features come because a particular customer or more wants to use it. So now they have access to it. It's there. They can try it out. Eventually, we collectively become more comfortable with it. It moves itself up into the stable portion of the release. And so it's kind of a classic open source software company way of doing things. I'm sure many of you have used a Windows beta or a Mac OS beta or whatever. It's a similar process.
And the same thing, just to JR's point to me originally was that, when you have a problem and you're trying to perfect it, you know all the problems, but you don't know what you don't know. If you put it out there, You can fix it, but you'll also hear about things that you don't know. So I'm out of time, but as a platform, we can open up network to innovation again. We can be a gatekeeper. We have a lot of partners. As an example, partners can craft an API completely on their own. We have Midukura, which did its own complete integration. We have Matt Stone, who, without telling us, built a complete API. So we are trying to say that we cater to this particular point that I want to say. You don't need any assembly. But if you want customization, you can. And we enable a rich ecosystem. So with that said, I'll have to stop my poor jokes and say thank you for listening to me. I hope it was valuable. I couldn't get to the demo, but I'm happy to show it later on.
So you just skipped the whole VXLAN stuff, right?
Yes.
Go ahead and fill it. Go ahead and fill it out. Is there a question? Yeah.
If there's a question, it's reasonable. We just want to make sure that you're able to get a kind of a broad perspective of what's going on.
Yes.
Or we just take that at the end
Yeah,
if
that
we
might
have
be
time.
that might be a good idea.
Move on.